Hi, Claire here, and this is our second transformation, and we're looking at translations. So that's a bit tricky to remember. Translations talk about a movement of a shape horizontally and vertically. The best way to talk about translations is using a vector. Now, a vector is much the same as a coordinate, but it's used in physics, engineering, and robotics. So it's a great thing to learn about. The first number talks about a horizontal change. If it's positive, it moves to the right over this way. If it's negative, it moves to the left over this way. The second number talks about a vertical change. If it's positive, it moves up, and if it's negative, it moves down, and it tells you how many places it moves. So we're going to use centimetres as the movement unit. So I've drawn here an equilateral triangle. Each side length is 6 centimetres. It's quite tricky to draw equilateral triangles. You need to find the midpoint and draw a vertical line, and then make sure that 6 centimetres meets the midline, and then check the other side. So this is definitely an equilateral triangle. Now I'm going to move this. I'm going to translate this equilateral triangle in the vector 3, -2. And sometimes you see these translation vectors with a capital T in front of it, and that just gives you a little warning that it is a translation vector. So it's going to move, each of these points will move 3 places to the right. So let's label them A, B, and C. So we'll move A 3 places to the right and then 2 places down. So 3 places to the right brings it to the midpoint here. 2 places down is here. So that is the image of A, or A prime. B is going to move exactly the same, 3 centimetres to the right and 2 centimetres down. And you can see it's on the same line as A, and that is the image of B, or B prime. C, 3 places to the right and 2 places down, and that is the image of C, or C prime. So we'll join these in the same order that they were joined in the original, and we have a congruent equilateral triangle. So exactly the same shape and exactly the same size. Okay, now I've got another question for you. What if I had moved that original ABC equilateral triangle to another position, and I wanted you to find out the vector? So this is A double prime, B double prime, and C double prime. Could you work out the transformation vector, or the translation vector, that has been used to move the original to this second image? It's really quite easy. All you need to do is to find out, say for A, how far it's been translated horizontally. So directly under A, and you make sure you're moving the same point, it's moved 12 units horizontally. So I'll write that down so I don't forget it. And how far has A moved up vertically? 6 units. So that second transformation vector is 12, 6. So it's moved 12 units to the right and 6 units up. This transformation vector is 3 units to the right and 2 units down. In our next tutorial, we're going to look at doing some translations on a Cartesian plane. So we'll draw a Cartesian plane and we'll work with coordinates as well. So thank you for your attention, and I'll see you in the next tutorial. Bye for now.